Welcome to our video on Pythagorean identities. So this is an idea in trigonometry that is going to give us some formulas that come from those basic trigonometric functions: sine, cosine, tangent, and their opposites: secant, cosecant, and cotangent. So let's go ahead and get started by talking about the reciprocal functions, which are sine, cosecant, right? We just flip those upside down and we get the other one. Easy peasy, right? Same thing with cosine and secant. Just flip them upside down and you've got the other one, and vice versa. Tangent, cotangent, flip those bad boys, we got the other one as well. So those are awesome to switch between. So tangent and cotangent, you just put one over and you've got the other one. Not too bad to switch between. We also know that the tangent of an angle theta is equal to sine over cosine. Now, we haven't really talked about that so far, but that is pretty easy to show, because if we look at sine, we know that sine is y over r, right? So y over r, and cosine is x over r. So if we divide these, we get y over r times, flip that second fraction on the bottom, r over x. What happens? Those r's cancel and you get y over x, which is in fact tangent. So it's kind of easy to show that one, but that's a great one to have in your pocket. If you are given sine and cosine and you want to figure out tangent, just take sine divided by cosine. That one's pretty awesome to use as well. So what happens if I want to switch between sine and cosine? How am I going to do that? None of these tools given really work. Now, I could draw the triangle and work out my missing value and figure it out that way if possible, if it's given to me as a fraction. But if it's given to me as a decimal, that's not going to work out too well. So let's see what else we can do. Hint, it has to do with Pythagorean identities. So recall this triangle that I showed you earlier, and this will just help us visualize the two legs, which are x and y, and your hypotenuse, which is r. And if we wanted to, we could use Pythagorean theorem to come up with the following formula. So if you remember, Pythagorean theorem is the square of the legs added together, so x squared plus y squared is always equal to the square of the hypotenuse, so the square of r. So this is a nice little formula that you can just come up quickly by using that Pythagorean theorem. Now we're going to use this Pythagorean theorem to actually come up with our Pythagorean identities. So keep this triangle in mind and keep this Pythagorean theorem. I'm going to show you how we come up with them. So this is a little sticky part, but I'm going to try to break it down. So the first formula, there's three identities that we need to come up with. The first one, we're going to start with our x squared plus y squared equals r squared, which is what I showed you before. We just got that using Pythagorean theorem. And we're going to divide all three of them by r squared. Follows our rule of what you do to one side, you can do to the other. And what happens is x squared over r squared, we just break down x over r, y squared over r squared is y over r, and then r squared over r squared, 1. So x over r, if you remember, is actually cosine of theta. Okay, if we go back to that original formula, you can see x over r is cosine of theta, and y over r is sine of theta. If you don't believe me, check it out. And you'll notice what ends up happening is if we rewrite these, okay, just flip these two, and it becomes sine squared plus cosine squared equals 1. That's our first identity, and he's going to be our little showstopper here, okay? Sine squared plus cosine squared equals 1. That's going to be the first identity that I want you to try and memorize. We're going to keep that in our pocket. It's going to come back in calculus as well. So I just like Big Bang. So I wish I were sine squared and you were cosine squared so that together we could be 1. Ha ha ha. Okay, let's keep moving. You can laugh later. Okay, Now, there's two more identities. I kept this one. I just wanted to show you the steps where instead of dividing by r squared like we did in the last one, we went ahead and divided by x squared. And what we ended up getting was 1 plus y over x squared. Well, y over x is the same thing as tangent. And then r over x is going to be secant. Okay. So secant was the opposite of cosine. So if we rewrite this, it's tangent squared theta plus 1 equals secant squared. So this second formula allows us to switch between tangent and secant, whereas the formula on the previous slide allowed us to change between sine and cosine easily. We just have to plug in one value and solve for the other. Okay, last formula, just stick with me. We're almost done with those formulas. Now let's go ahead and divide by y squared. So we're dividing all of them by y squared. So you get x over y plus 1 equals r over y. X over y, of course, equals cotangent. And r over y equals cosecant. I don't expect you to have those memorized yet, but work on memorizing those, right? Okay, so that was our last one. So it allows us to switch between cotangent and cosecant. So these three identities allow us to basically switch between any of those trig functions. So that's pretty awesome. In fact, let's go ahead and look at how to use those trig functions to switch between them given certain information. So here's our Pythagorean identities. There's the three we just learned. And we're going to go ahead and do number 1 first. So number 1 asks us to find sine given that cosine. So we know cosine of theta equals negative pi, well, square root of 3 over 4. It's getting excited about pi. And sine of theta is greater than 0. We're going to ignore that sine of theta is greater than 0 right now. I don't care. I'm just going to look at this part first. Sine of theta and cosine of theta. Cosine of theta is given, and we need to find sine of theta. Now, is there a trig identity that involves just sine and cosine? Well, yeah, the first one, right? Sine squared plus cosine squared equals 1. So let's plug in what we know and solve for the rest. So sine squared of theta plus cosine squared of theta equals 1. Well, we know cosine of theta, so we can plug that in. Negative square root of 3 over 4 squared, right? We're squaring that cosine. Okay, fill in the rest here. Okay, now let's square this. Well, if I square a negative, that becomes a positive. Square the top and the bottom. Square root of 3 squared is just 3. 4 squared is 16. Now I need to subtract 3 over 16 to the other side. Get that by itself. So we have sine squared of theta equals, let's change that to 16 over 16 minus 3 over 16, which is going to give me a nice, okay, not really nice, but 13 over 16. Yay! So sine squared theta equals 13 over 16. Well, how do we get rid of that square? We square root. And what you do to one side, you got to do to the other. So square root that, you get sine of theta equals positive or negative, we'll deal with that in a second, square root of 13 over square root of 16, which is 4. Okay, now 2 seconds ago I just said plus or negative. Which one is it? Well, it said sine of theta is greater than 0. Remember that part I said just ignore it for right now? Doesn't matter? Well, it's coming back. So sine of theta is greater than 0. That means sine of theta is going to be square root of 13 over 4. Sweet! We just used our Pythagorean identity to find our missing sine value. So that's exactly how you would use it to find an opposite one. Let's try that again, but for the next one, let's go ahead and find cosecant of theta, given that cotangent of theta equals -1/2, and theta is in quadrant 4. So we are trying to find cosecant, but we know cotangent. So we want to choose a Pythagorean identity that contains cosecant and cotangent. Well, looks like it's right here, right? So let's go ahead and plug that in and see what we get. So 1 plus cotangent squared of theta equals cosecant squared of theta. And plug in what we know, cotangent. So 1 plus -1/2 squared, because we're squaring that cotangent, is going to be equal to cosecant squared of theta. Okay, let's square that off. Negative squared is positive. That turns into 1/4 equals cosecant squared of theta. And 1, we can just change it to 4/4. So 4 plus 1, 5/4 equals cosecant squared of theta. How do we get rid of that square root? Well, you betcha, we got to square root both sides. Make sure we square root the top and the bottom. So this is either positive or negative. Square root of 5/2 equals cosecant of theta, right? Because the square root and the square cancel each other out. Now we have to decide, is it positive or is it negative? Well, theta is in the 4th quadrant. So over here, in the land of quadrant 4, we need to remember that cosecant is r over y. Okay, so r has to be my hypotenuse, right? R is going to be my hypotenuse, whatever it is. And my y is going to be this value here. So that's, oops. Let's make it look like an actual triangle. Yeah, okay. Doesn't really matter. Okay. So here is your x and here is your y. Now in quadrant 4, your x is going to be positive, right? But my y is going to be negative. Since cosecant is r over y and my y has to be negative, that means this value is going to be negative square root of 5/2. So that's playing around. The positive and negative, you kind of have to play around with it a little bit to make sure you understand fully what those mean. But if you use the basic formula for the functions, we can make that drawing and figure out which value it has. So just always go back to those triangles. Okay, so that was the Pythagorean identities. Hopefully you saw why they're so important. They're going to help us convert between trigonometric functions that we normally wouldn't be able to transfer between. So good luck, and remember to practice, practice, practice.